You were told the internet resides in the cloud. It is a brilliant marketing lie. The internet does not exist in the sky. It lives at the bottom of the ocean. Right now, 99% of all international data travels through a physical web of submarine fiber optic cables. Every single email, every high-frequency stock trade, and every video call is routed through these underwater arteries. We are talking about $10 trillion in financial transactions, crossing the ocean floor every single day. If these cables are severed, the global economy halts within a matter of milliseconds. For decades, this infrastructure was owned by national telecom consortiums, but a silent, aggressive shift has occurred. Over the last 10 years, big tech companies have quietly seized control of the ocean. Behind this invisible monopoly lies the sheer engineering audacity to shoot light across an ocean, and the brutal economic math that forced Google and Meta to spend billions buying up the bottom of the sea. To understand the financial war, you have to understand the physical constraint. A submarine cable is built to survive an incredibly hostile environment. Data is transmitted through this glass via lasers pulsing billions of times per second, relying on a principle called total internal reflection. But what exactly is that data? At a fundamental level, every video, image, and text is just a sequence of binary code, zeros and ones. In a standard copper wire, those are electrical pulses. But underwater, they are translated into pure flashes of light. Because the core and the outer cladding of the glass have different refractive indices, the light hits the edge and bounces back inward, trapped in a perfect optical corridor. But there is a massive physics problem. Glass is not perfectly transparent. As the light travels, it suffers from attenuation. It scatters and absorbs. Left entirely alone, a data signal fired from New York would completely degrade into useless static before it ever reached the coast of London. To solve this, engineers use specialized optical amplifiers. Specifically, erbium-doped fiber amplifiers. They are spliced directly into the cable, every 80 kilometers, cutting through the dark. Inside the amplifier, the fiber is doped with erbium ions. A secondary pump laser continuously fires energy into these ions, exciting them. When the exhausted data signal passes through, the erbium ions release their stored energy, perfectly cloning and amplifying the data photons without ever converting them into electricity. It is a purely optical process, and it requires immense power. These cables must carry thousands of volts of continuous direct current from the shoreline just to keep the amplifiers alive across the abyss. This level of deep-sea engineering is violently expensive. Laying a modern transatlantic cable costs roughly $300 to $500 million. For most of internet history, tech companies simply leased bandwidth from the telecom consortiums that built them. So why did tech giants suddenly start building their own? The answer lies in the shifting dynamics of bandwidth economics. Around 2010, the sheer volume of data required by video streaming, social media platforms, and cloud computing broke the traditional leasing model. When you lease a cable, you pay per gigabyte. Your costs scale linearly with your traffic. But when you own the cable, your marginal cost drops effectively to zero. By investing the massive capital expenditure upfront, Google and Meta locked in fixed operational costs, creating an insurmountable competitive moat. A new startup trying to build a data-heavy platform today has to pay telecom rates for international bandwidth. Google does not. They own the pipe. This economic reality has triggered an infrastructure arms race. Tech giants now own or hold majority stakes in roughly 75% of the world's submarine cable capacity. Driven by the massive bandwidth demands of artificial intelligence, they are vertically integrating the global internet. They design the software, they manufacture the proprietary servers, and now they own the physical glass resting at the bottom of the Atlantic. The internet is no longer a public, decentralized web. It has become a series of private corporate highways. This is not a hidden conspiracy. It is a straightforward infrastructure monopoly. Controlling the physical glass gives these platforms an absolute economic advantage. But while the data flows seamlessly underwater, its next major bottleneck is completely landlocked. It takes a staggering amount of land, physical space, and cooling infrastructure to process the petabytes surging off those deep-sea lines. The modern geopolitical battlefield isn't just fought over code or bandwidth. The industrial war for the world's land, power grids, and data centers is just beginning.